All right, you guys, let's take a look at practice number 2. I'm sure your group and yourselves have, you've all done a great job here. We've got a collision with two cars, one of them chasing the other, and then it smacks into it and sticks together. So your very first thing you got to figure out is what the heck kind of a collision is that? And that is an inelastic collision. If you didn't classify it before, you can classify it right now. All right, an inelastic collision is important because once they stick together, the mass is combined and the final velocity is the same. So even if you decided to go the algebraic route completely with this, that's fine. Or you can solve it with the chart, but it gives you some insight as to how you would do that. So if we're going to do this with a chart, let's put our cars and our totals together, right? We want before, after, for each of these, and we should be able to find it. So according to our question, car number 1 is 1,250 kilograms. It's moving with 32 meters per second. When I multiply that together, I get 40,000 kilograms meters per second. My second car is cruising a little slower ahead of it, 875 kilograms. It's moving at 25 meters per second. So hopefully, this was the quick part, right? You had this, you're like, okay, this is all good. No problem, I'm out of room. So I'll just leave the unit off for now, which I know is very naughty, but oh well. All right, so 875 kilograms meters per second. That's my total momentum. I know that momentum is conserved, therefore it's got to be the same over here. And even though I don't know the velocity of either car when it's done, I do know that they have the same velocity. So that being said, I can use the same variable v to describe their velocity. And I also know that the momentum of A plus the momentum of B has got to be equal to this 61,875. So I can actually kind of put it just like this, right, in a nice little algebraic equation. When I do the math, it looks like that. And my final velocity, I'm almost out of room, but not quite, 29.12 meters per second. All right, so there's my answer. If you used the chart method, hopefully we have the same results. If you decided to go, full algebra because I don't need no stinking chart, then let's consider this. All right, M1V initial, right, for the first object, the first car. M2 VI for the second car equals M1 plus M2. Now this is a fancy way to write it because we know that the masses are going to stick together, so we can just write it this way. Yes? You could write it separately as well as two separate amounts like this. Of course, we would change the VI to VF. So this is where we start plugging in our values for this. So 1250. Oh, my eyeball is itchy. 32. Who needed to hear that? Nobody. All right, here's our mass. Here's our second velocity. All right, so there's my left side of the equation. I'm just about out of room here. So here's where I'm going to add those masses together and just save myself a step. I'm just going to do it right away. Okay, so that's the 1250 plus the 875 gives me 2125. Over here, I'm going to get, again, these numbers should look familiar. 21,875 equals 2125 VF. Oh boy, I think I might have seen that one before. It's right down here. Right? So we've got the same darn thing. We can figure that out. This combines to this, our 61,875. And we've got our 1250, yeah, our 2125. Oh yeah, there it is. Ta-da, they match. So again, we're going to come out with the same exact answer. So hopefully, that was straightforward and easy, and you're ready to rock and roll now for the rest of class.